Understanding impurity limits in biochemical analysis. When developing or analyzing chemical substances, especially in biochemical research, defining impurity limits is critical for quality, safety, and regulatory alignment. But how exactly do we determine the threshold for known, unknown, and total impurities? In this video, we'll clarify how these limits are defined and why they matter in non-clinical biochemical applications. Defining known impurity limits with data-driven precision. Known impurities are well-characterized substances identified during synthesis or storage. Their limits are typically based on toxicological data, historical manufacturing performance, and analytical sensitivity. These impurities often have qualified reference standards, allowing for precise quantification and tighter control thresholds, typically in the range of 0.1% or above depending on the nature and use of the product. Setting limits for unknown impurities in biochemical samples. Unknown impurities are those without structural identification, but detected through analytical methods like HPLC or LC-MS. Since their toxicity profiles are unclear, regulatory guidance often dictates stricter thresholds, commonly capped at 0.1% or lower. In biochemical workflows, this conservative approach helps mitigate unexpected reactions, especially during preclinical research or molecular testing. Total impurities, a comprehensive quality benchmark. Total impurities represent the sum of all individual impurities, both known and unknown, present in the sample. The total impurity limit ensures overall purity remains within acceptable bounds. For example, if individual limits are observed but the total exceeds 2%, it could indicate issues in synthesis, efficiency, or stability. That's why total impurity limits are key indicators of product integrity, especially for custom chemicals or biochemical intermediates. Impurities at BOC Sciences. At BOC Sciences, we offer an extensive portfolio of impurity reference materials and custom impurity synthesis services, supporting research, quality control, and regulatory documentation in various biochemical fields. Whether you're working with APIs, peptides, oligonucleotides, or other research molecules, we help you achieve accurate impurity profiling and compliance-ready data. Reach out to our team to learn how we can support your next biochemical project.